problem that you guys just did in the math moment. It's just being asked a different way. So it tends to work that when math books say, if this is f of x, plug in x equals -2. You guys are really good at that. Then when they start writing it more like this, you're okay usually when the numbers show up. And then when we start putting something more than -2 in that set of parentheses, it tends to get confusing for people what we're plugging in. And some of you might be really good at this, and then others of you might struggle. So this is basically, like we said, doing the same thing that you just did. Remember that f of -2, the way it's asking the question, is just the name of the function. So when you're finding f of -2, so I'm finding f of -2. This is the name or the label. The stuff on the other side is the work. Just like when you guys plugged in -2, you left the left side alone and did all the calculation on the right side. That's what we're doing here. I know. Don't be amazed by the magic. Yeah, okay. Okay. All right, so I'm going to do exactly what you guys did in the math moment, and I'm going to plug in -2. And all you guys are going to do is watch this magic pen write because you're so amazed. Yes, okay. All right, so just like you guys plugged in -2, so did I. The difference is I'm going to keep this label all the way to the end as part of my answer to show people what I plugged in and what the function was called. This function's called f. Okay, sometimes they use g or h or whatever other letter that they want. So then I just have to do some calculations. I don't know, -2 to the 5th power is -32. -2 to the 4th power, 16. Keep this for now. Okay. So I did my exponents and my order of operations. Now I'll go through and do my multiplication and division and then my addition and subtraction. So I'll go ahead and multiply these things. If you see me make an arithmetic error, please tell me it's happened more than once. Okay. All right, so we get here. Thank goodness the positive 10 and -10 will cancel out. And we get -112. So usually, you guys might leave -112. I would be completely okay with that. But I write it like this to emphasize to you guys that this is the name of the function. Do you see me dividing by -2 on both sides now or anything like that? No, that tends to be a common error that people make. They see this number over here and they think they're trying to get f alone. But f is not a variable. F is the name of something, and you're showing me what you plugged into that something. So this whole thing is like the name of what you did, and then your result is on the other side. And the reason that mathematicians like to use this notation is because then, instead of you just saying like -112, they know what you plugged in and what you got out. So if I had to like plot it on the graph, I know like, oh, this is the x and this is the y all in one little statement or something like that. Okay? So we have to get used to that notation. Any questions about just writing it like this or plugging it in? Yes, sir? No. So remember, this is just a name. It's not, you're not trying to get f alone. You're not canceling anything out. This is just telling somebody, I went to the function that the book called f, and I know they called it f because they labeled it with that when they wrote it, and I plugged in -2. Then I got this answer. So this is like an explanation of what you did or a label. And this is the actual like arithmetic part of it. So they don't coincide. We don't do anything with them together. Okay? Any other questions about that? All right. So now it's getting a little more complicated because, well, they changed the name of our function to p instead of f. Don't freak out about that. Okay, just find the one called p. There it is in the problem. All right. What are we plugging into this function called p? A plus 1. And that means when we simplify, not only do we expect to see numbers in our polynomial, but what else would I expect to show up there? Like, am I going to get -112 for this problem? No. There's going to be A's in it and stuff, right? Because I'm plugging in something with A in it. I don't know what A is. I can't get rid of it. So you need to be comfortable with that. Okay? So as the setup, for those of you that struggle with plugging in something that's more than a number, here's my advice for structure or organization. Notice the way they write the function is with an x in the parentheses, right? So they usually name it with an x inside of the parentheses, and then on the other side, x shows up. when you're putting something new inside the parentheses, whether it's a number or another letter, or maybe it's like 3x plus 2, it still has an x, but with a bunch of other stuff with it, every x on the other side is getting replaced, just like we did before with negative 2. It just tends to be a little easier when it's a number. So if you struggle with that, my advice would be take the function and write the whole thing, and everywhere there's an x, leave an empty set of parentheses. Okay, some of you don't need this, but others of you are like, yeah, every time something shows up weird in these things, I don't know what to do with it. This is what I'm going to do. I'm going to rewrite the function, and everywhere there was a set of parentheses with x, or everywhere there was an x, I'm leaving an empty set of parentheses. So then my function looks like this, just bunches of empty sets of parentheses. Now what I'm going to do is follow their directions. They changed the problem. Instead of p of x now, they want me to do p of a plus 1. That means they want me to plug in a plus 1 every place there used to be an x. So remember, this left side is just the name, right? The label. I'm not doing any math over here. I'm just showing people what I did. All my work is going to be on the right side of the equation. On the right side, everywhere there used to be an x, there now needs to be whatever they put in this parentheses. So there now needs to be an a plus 1. Is that okay with everybody, just the replacement of it? Then we have to go through and do a bunch of order of operations stuff, and this one has a cube in it. I took out all the other cubed ones in the notes, but just to go through this once to remind you guys how it kind of works. So as a side note, I'm going to add an extra page in here, and we'll come back to this slide. But off to the side, just a reminder for you guys to get what a plus 1 to the third power is, because we're going to go through and do our exponents before we do our multiplication, division, addition, subtraction, that we need to do a plus 1 times a plus 1 times a plus 1. It's not just like cubing the a and cubing the 1, okay? Because first we have to multiply these two together using the process of FOIL, right? Or distribution, however you guys think about it. So what you get when you do that in combined like terms is you end up getting this. Okay? But that's only for the first two. Now you have to multiply that times the third a plus 1 from your cube. Okay? This is like FOIL, but it's bigger. But basically, every piece of one of these has to multiply every piece of the other for us to get the final answer. So let's say I take a squared first and it multiplies a, and then it multiplies 1. Then let's say I take 2a and it multiplies a, and then it multiplies 1. Then I take 1, it multiplies a, it multiplies 1. Long, yes, difficult, not if you know how to distribute and multiply. So we'll take up some space on your paper, but not the most challenging, like, you're not going to have to think about it for 5 hours, you're just going to have to work through it real quick. Okay. So then I'm going to combine the like terms. There's one cubed term. There's a squared plus 2a squared, so that makes 3a squared. There's 2a plus a, so that makes 3a. And then plus 1. So when I go back to the problem I was working on, the set of parentheses that said a plus 1 cubed, I'm going to replace with this. The set of parentheses that said a plus 1 squared, I'm actually going to replace with this. I know that that's what a plus 1 squared is because I did a plus 1 times a plus 1 to get that. Okay? Is that all right with everybody? So a little side arithmetic. I'm going to go back and plug those things in. So let me go back to my previous page. All right. So this part right here became a cubed plus 3a squared plus 3a plus 1. And it still had this stuff in front of it. The a plus 1 squared is a squared plus 2a plus 1. Still has the negative in front of it. Is that all right? So go off the side of your paper, do whatever stuff you have to do to finish the order of operations. So now that we've done the exponent part of it, we want to do all the multiplication, which in this case is a lot of distribution. So here we need to distribute the 4. Here, even though there's not another number in front of here, don't forget to distribute the negative to each of the terms. And then here we need to distribute the 2. So we're going to get 4a plus 4. We're going to get minus a squared minus 2a and minus 1 when we distribute the negative, plus 2a cubed plus 6a squared plus 6a and plus 2. And then we can just combine together all the stuff. Again, I took out all the other cubed ones on this because you can see that when you plug in like a polynomial and not just a number, cubing or taking to the 4th power or the 5th power would be really, really annoying. So we're just going through it once so you can understand how to do it if it comes up. So we're going to put the terms in order of the highest power or highest degree. So we'll start with 2a to the 3rd. I'm just going to cross them off as I go so that I don't make a mistake. So 6a squared minus a squared would be plus 5a squared. And then 4a minus 2a plus 6a would be like 8a. And then 4 minus 1 and plus 2 would be like 5. Now, you guys don't have to go factor any of these afterwards. Another common thing I see is that you guys think once you've multiplied something out, if it's factorable, you have to go factor it. You don't have to factor something unless someone asks you to, or unless factoring is something you're using to solve something else. Okay? So if somebody's asking you to do one of these operations, even if this was completely factorable, I'm just going to leave it like this. Okay? I'm not going to touch it. But notice again, the name is right here. I don't take a away from both sides. I don't put a plus 1 on the other side because this is just a label or a name. All the arithmetic was done right here to make it as simple as I could. Is that all right with everybody? So you have a structure for plugging in. If you struggled with plugging in before, leave those empty sets of parentheses to do that. And then if you get complicated stuff, go off on the side and do it, and then come back and try to keep with your order of operations. Okay? All right. Oops. Let's there. Okay, we're going to set this one up, and then we're going to let you guys work on it and see if you can do the simplification part, right? So this has some different things going on. What are some different operations that you see? Like, where are you plugging stuff in versus places that you're, like, just multiplying stuff together? So, like, look at the first term. 4, and then it has brackets, and then it says p of x. Is the 4 being plugged in for x? No. What is the 4 doing? It's multiplying. And what is it multiplying? P of x. What is P of x? Right. So really this is saying you have 4, and yes, it's multiplying something. The name of what it's multiplying was P of x. But if you actually want to do the multiplication, don't keep the name there. Actually plug in the thing that is P of x. So if we look at the problem, P of x is that. X squared plus 2x minus 4. They didn't change the x to a different letter. They didn't do anything like that. So I didn't have to plug anything new in for x. I just had to write the equation that they gave me. Okay? Then it says plus, what is the 3 doing? Multiplying something. So again, the 3 is just going to multiply some stuff. Okay? What is the 3 multiplying? Good. P of x plus 2. So is it just the same function that we wrote down right here? Are we just going to write down x squared plus 2x minus 4? No. What do we have to do? Not multiply it by x plus 2. What is x plus 2 going to become? So let's go off to the side and think just about this. What would p of x plus 2 be? What is that? Because that's what we need to know. Whatever this is what we need to fill in here. Does that mean you take the p function and you multiply it by x plus 2? No. It means you take the p function and do what? Okay, good. So somebody said add 2. Let me make off to the side here on my whiteboard a little note that these things are different. So if the plus 2 came after the function like this, you would just literally add 2 onto the function. But because our x plus 2 is all in the parentheses here together right after the p, x plus 2 needs to be plugged in and replacing x, just like in the last problem how we took all the places x would be and replaced a plus 1. That's what x plus 2 needs to do here. So this is going to be x plus 2, squared plus 2 times x plus 2, and then minus 4. This used to have a cube in it. I took out the cube, okay? So I know it has a square, which makes it a little bit harder, but at least it doesn't still have a cube in it. So this is p of x plus 2. The name is p of x plus 2. The function is what p looks like once x plus 2 has been plugged in. So I don't know about you guys, but rather than writing this stuff in here, I'd like to simplify it first so that when I do put it in here, I can then do my multiplication and stuff like that and finish. Does that make sense? So I'm going to finish simplifying this a little bit. So like x plus 2 squared, I need to figure out what that is. So you guys need to go off to the side if you have to, and on your paper multiply x plus 2 times x plus 2. Some of you are really familiar with it, and some of you aren't. So it's just going to depend on how close you are to that. So that would be x squared plus 4x plus 4. Then here you have to distribute the 2, so you would get 2x plus 4, and then we have a minus 4. So we have x squared plus 6x plus 4. So this is like my little side note. I didn't know what p of x plus 2 was. It was hard for me to understand, mumbled with all this other stuff, so I took it off to the side. I went through the process we went through last time of plugging it in and simplifying it. So this is p of x plus 2. So anywhere I see p of x plus 2, I can now replace it with x squared plus 6x plus 4. Is that all right? So in here, I don't want a name. I want something I can actually multiply with the 3. So I'm going to plug that in. Okay? Then go ahead and distribute your 3s and 4s and combine your like terms, and then you'll get your final expression. So take a minute to do that, and then if okay, so you have 7x squared plus 26x minus 4 when you finish simplifying. And yes, you could set it equal to what you had originally, or if I make it this complicated, you guys can just leave it like this. But if it's something as simple as like f of something, write that name usually. Okay. All right, so the last two things we're going to be doing is we're going to be trying to apply this. So the next couple problems are actually going to mirror the directions in your homework. So here's what I want you to be aware of. We use the old pre-calculus book, so it has a lot of the material in it that we need. But the way that the questions are being asked are to prepare them for calculus questions in the future. So the way they're asking a question is exactly as the student's going to see it later on when they find out this formula is actually something from calculus. I like the question because it has you guys practice all the things that you need to do. But clearly the direction part of it, we don't need to focus on that right now because our goal in here is not to prep for calculus. That doesn't mean that that's not your ultimate goal or that the math skills here aren't needed for that. That's just not our purpose of this course. So the next two problems have some kind of thick directions in them, but please know that I just modeled the directions after the way you're going to see it in your homework tonight. That's from your book, so that you know what to do when you get to those problems. Now you're going to know, like, oh, I'm basically just doing this. So you don't even have to write down all the words if you don't want to, but you might want to make a note on your notes that, like, when you see this in the homework, we're really just using it this way, or you can copy it all down. But do you guys kind of get what I'm saying? Okay. You're going to see the directions this way. I don't want you to be confused by the words, but I want us to practice using the formulas because they're good practice with this skill. All right. Oh, nice formatting yet again. Oh, it won't let me move it. How sad. Okay, I'm just going to move it down here. Because this is not supposed to be there. It's supposed to be here. No, not like that. Sorry. Yeah, I know. Trippy. It's supposed to be like that. Okay. So some of the questions are going to ask you to find the average rate of change between 1 and x. I do not expect you to know a formula for average rate of change, okay? However, this is the formula. So basically, when the problems say this, we just have to be using this formula right here. Okay? The reason that I want us to use the formula is because notice it practices the things that we were practicing. See f of x, see f of 1. We clearly have to plug stuff in for that. So it's going to help us practice this plugging in idea. It's not a bad problem. The words, though, are not something that we need to use for something later. So when it says rate of change, you're going to use this formula. It'll be in there. The reason it puts this little x is not equal to 1 thing, because if x was equal to 1, your denominator would be 0. So in math, when we want you to do a problem that has some limitation like that, technically we're always supposed to write that. You guys probably don't care and would do the problem anyways, but they have to write that because it wouldn't make sense in that situation. Okay? So basically, we're going to be calculating this. Okay? F of x minus f of 1 over x minus 1. In order to do this, you need to know what function f they're talking about, and they can change the function. So in your homework, you'll be doing maybe more of these than just one, but each time maybe with a different function. Okay? So this time, the function we're going to use is that f of x equals 1 minus 3x. All right. So the question is, to calculate this, if we know that this is our function, what are the things that we can replace in this problem, and what are things that stay there to be simplified later? So in this formula, what should be replaced with something simpler? So f of x. F of x is a name of a function. We need to actually put the function in there, right? So f of x is 1 minus 3x. So this right here is going to be replaced with 1 minus 3x, the whole thing. Then it has a minus sign after that. I want to keep that in the problem and not mess it up. Is there anything else up here that needs to be replaced with something substituted? Okay, good. So what does this mean right here, this next set? How do we say that? So we say it as f of 1, and what does it mean that we go and do? Yeah, we plug in 1 to the function f. So I'm going to go right here and go ahead and figure out what f of 1 is. Is that okay with you guys? I kind of like to do that simplifying work off on the side before I plug it in. Otherwise, it gets really complicated. And remember, that just means the name is f of 1, and I'm going to take the function and plug 1 in for x, and then finish calculating, just like you guys did in the math moment. So I get that f of 1 is equal to negative 2. So negative 2 is going to replace f of 1, because I've done that calculation, and that's what it's equal to. So this becomes negative 2. What about in the denominator? Are there things for us to substitute? No. X is a variable. You might not like that it's a variable, but it is a variable, and it can stay there. There's nothing here that tells you what x equals, and 1 is the number 1. So in the denominator, we still just have x minus 1. Okay? Now what we're going to do is we're going to simplify and combine anything we can in the numerator, and then we're going to see if anything kind of cancels from our fraction numerator and denominator. Okay? So in the numerator, I'm going to kind of write the negative 3x because I see that's the only term with x in the numerator. Then I have a positive 1, and this minus a negative is essentially going to make this a positive 2. So those are going to combine together to be 3. Okay. Now a little bit more of Algebra 2 review within this problem. Can we just go and cancel the x's? No. Right? Whole factors have to be able to cancel whole factors. So the only way anything is going to cancel here is if this whole group or factor of x minus 1 has a whole nother group or factor of x minus 1 also in the numerator, then we would be able to cancel them. Okay? Right now, it doesn't look like there's an x minus 1 in the numerator. Is there anything that we can do in the numerator? Yeah. Good. We can factor out a negative 3, so that would leave x here, and then it would leave minus 1 there. So now can we cancel something out? So x minus 1 and x minus 1 can get canceled out. So our result is negative 3. Seems kind of weird because we had x in our problem originally, but it just so happens that the x got canceled out, and we were able to get that. So do you guys understand, like, despite what the words are saying, average rate of change, I'm not testing you on average rate of change. I'm just seeing, can you take a little bit more complicated of notation and do what we've been doing? Okay? Yes? Yes, I would give you the formula like this and a function like this and ask you to find this. Okay? So normally on your test, what I do is I list like 3 functions at the top, like f of x, g of x, and h of x, and write out what they are. And then I'll give you problems like, go find f of 2. Go find g of x plus 3. But all the things will be listed at the top that you need to reference. Okay? All right, so there's one other formula that you're going to see in your homework. Okay, lots of words. You do not have to write down all the words. Okay, I'm trying to emphasize this. But you're going to see this formula in the book, and it's going to have all these words surrounding it, and you're going to be like, what is she asking me to do? Secant line? I don't even know what a secant line is. I don't care that you know what a secant line is. Okay? My focus is on that formula right there. Can you take a function and can you apply it into that formula? So all you really need to write down for this example, as long as you understand not to get tripped up by all the words in your homework, is we just want to focus on this. Is that okay with everybody? So again, I'm trying to use the resource we have. It has some good problems where you have to practice this skill, but it hasn't been embedded in a context that you guys don't need to use right now. Okay, so just pull out the formula and we're working on the calculation. And then in this case, we're given this function. So nothing else up there pertains to us. I'm not saying ignore words and problems that have them. I'm saying in this case, I'm giving you permission to completely not worry about what your book is talking about except for how to do the calculation right now. Okay. All right. So same thing as last time. What things need to be replaced? Yeah, so f of x needs to be replaced. What else? And f of x plus h. Are you guys on board with that? So both of these things are names of stuff, but we want to replace them with what that stuff actually looks like. Okay? But h is a variable, so it's going to stay in there. So we're going to have a minus sign. We're going to have h in the denominator. But there should be something that gets plugged in here for f of x plus h, and there should be something that gets plugged in here for f of x. Which one do you guys want to replace first? Which one's easier? F of x, right? They tell us what that is. That's easy. Okay, so f of x is negative 3x minus 5. Okay? Required except for reading properly and understanding what the notation means. All right, what about this guy? F of x plus h. What am I going to have to go do off on the side or whatever to figure out what is getting replaced in here? So what does f of x plus h mean? Okay, let's plug it into f. So we need to go find the f function. We have the f function right here. I'm just going to rewrite it, but with empty spaces where x is, because x is not what I want plugged in anymore. What do I want plugged in now? X plus h. So I put it on the left side as part of the name, and then I put it on the right side everywhere that x used to be. And then I clean it up, meaning simplify however I can, right? So negative 3 times x, negative 3 times h, and a minus 5. So f of x plus h is equal to negative 3x minus 3h minus 5. It has x's and h's in it, but you know what? I kind of expected that because my problem is showing me x's and h's plugged into stuff. Okay? So I'm now going to go back to the problem I'm working on. I'm going to plug in this expression. Now I just got to try to combine like terms and stuff. Don't forget your signs, okay, guys? After you do all of this work, please don't forget that this one minus sign right here needs to distribute to each of those, things like that. So I get negative 3x minus 3h minus 5. When I distribute this negative, I get plus 3x and plus 5. And that's all on top of h. Okay? So negative 3x and positive 3x will cancel each other out in the numerator. Negative 5 and positive 5 will also add up to 0 or cancel each other out in the numerator. So I'll just be left with negative 3h over h. Is that my final answer? The h's can cancel, right? Those are factors. And so my final answer is just going to be negative 3. The final answer to everything in the paper is not negative 3, but it just happened to be in both the problems. what we're looking at. Okay, is this all right? So you're going to get to these problems in the homework. You're not going to freak out about the language they use, like secant line and stuff like this. You're just going to let your eyes focus on the formula they give you and the function they give you and using those things to get through the different calculations. Okay?